Hello everyone, I hope you are doing good. In the previous video, I did a project, but I saw that the audio was lagging in the video or the video is going further. So that was due to some technical error. I hope still you understood the code and you can see the code on GitHub and try to figure out everything. If you're facing any difficulty, you can comment out. And before starting the video, I want to say that if you have any feedback for the channel, means you're like not liking some things or you want some improvement in some place, you can just comment out so that we can make this channel a better place to learn C++. So that was just for starting. In the previous lecture, we learned about linked list, single linked list. I hope you got all the basic concept. You should get the basic concept of single linked list so that we can move further to double linked list without any difficulty. If you are facing any difficulty, you can comment out and I'll try to solve it. After completing double linked list, there is a circular linked list, but before that, we'll do some exercise so that you understand both the linked list in a better way. If till now you did not get, I hope in the exercises you'll get it in a very good way. So today we'll start with double linked list, but before starting, I want to give you a just description about double linked list by using a figure that was earlier used in single linked list. So let's go to the figure. So this is the previous image that I showed you in single linked list. I hope you understood this single linked list figure in the previous video. Okay, I'll say one more time. In single linked list, all the nodes are divided into two parts. Means each node have two parts. That is the data. Okay, I'll take a pen here so that you know which I'm pointing. If you can't see my cursor, okay. Each its linked list, its node have two parts, the data part and the pointer part. So there are different in the data we take all the input here, and in the pointer we just point to the next node. So there are many nodes, linked lists are made of many nodes connected with each other. In a single linked list we can point to the next node, means you can see that there is a pointer here and this is pointing to this node. So that is the benefit of single node linked list, sorry. But there is one problem, we cannot go to the previous, means if we are in this third one we cannot go here, means it doesn't give us a privilege to go to the previous node. So this is the drawback of single linked list, and thus we have the introduction of double linked list. So I'll take to the next slide so you can see the double linked list. Okay, this is double linked list. You can see here it's written double linked list. So what is the difference? Here you can see that this is divided into three parts. We have previous and next. This is the main benefit of double linked list, means we can go either in the backward direction or we can even go in the forward direction. Means it have both. It have the previous pointer as well as next. But in single linked list, as you saw in previous video, if I draw here, single linked list have only two parts. One is for the next, means going this way only, and the second is the data. You can just write D here. One is for the data and one is going to the next. But in double linked list you can see there is a previous, means you can go in this direction also, and this direction is possible, means you can go in both direction, means you can either go forward or backward. This is the main benefit of double linked list. So we'll be doing some code. In the code you'll understand better. And there is one more thing, you see that the last one, the last node and the first node is connected to null, means the first node in the previous it is connected to null and the last node in the next is connected to null, whereas in the single linked list only the last one is connected to null but first one is not connected to null. So these are the main difference in single and double linked list. We'll go to the code, then you'll understand it better. So let's jump to the code. So you can see here we are in the double linked list C++, and I have just included this data. This is just a simple code. I hope you got all the lines. Let me say from the beginning. So these two lines are always used, so there is nothing problem in these two lines. But okay, this is here we added a class. In the previous single linked list we used structures, but this time we are using class so that you get both the concept in a clear way. We are using a class and we'll use some function that is not linked with this class. I hope you are getting my point. When we complete the code you'll understand better way. So we are giving an integer type data. Okay, I'll just open up the previous lectures code so they understand better. I hope you can see the code. So this is from the previous video. We have used structures there and a class to link it. So I hope you got this, but this time we'll use directly a class instead of this structure. I hope you're getting this. Okay, now let me go inside the class. Inside the class we are using three members. One is the for taking the input type data, that is some integer type. that we did in the same in the structure taking the data. And here we created two nodes, previous and next. Okay, that's not the slide I want. We had only the next pointer, but you can see in double linked list we have two pointers, the previous and the next. So that is the main difference, because we wanted to point to the previous as well as the next. I hope you are getting this. And in the int main we just created an instance of the class in which we are giving the head is equals to null. In the previous we decided to add a constructor. You can see here in the linked list we added a constructor where we added null, but here we are assigning it directly to null so that we don't need constructor inside it. So this is the basic code. Today we'll do insertion and displaying. So today we'll do insertion and displaying. So these are the two things we are doing. Insertion will insert in the front, and in the next video we'll do it in the end and in the random position. So today we'll do insertion in the front and displaying what we inserted. So let's start a code. So first of all we'll create a function called void, and we'll name the function add node, so that it becomes easy to understand what we are doing. And inside this we'll add a number. We'll add some more things, but first of all we need to add an integer because we want to add it inside the data. So I hope you are getting this till now and it's not too slow for you. And now we'll add one more thing. We'll add a node that we wanted to do. We'll just write instance of a class node as a double pointer and name it something like node reference. We'll just name it node ref, so it becomes easy that we are reference to the node. And here now we add some condition to add nodes. First of all we'll create a new node. Let's create a new node of type node, and we'll write new node is equals to type of node. So we are creating a new node. So I hope there is nothing new here. Everything you understood this line. We are just creating a node using dynamic memory allocation. Now what we need to do, we need to enter the data inside this node because we want that every node should contain a data. We'll just write new node, okay, new node, and just put the data inside. Data is equals to, so just adding the data. Now we entered the data. Now we want one more thing. We want that we need the previous and next. We want to take the previous and next of this new node. So what should be the previous? First of all it should be the head, so we'll take previous equals to null because we want that first of all the previous should point to null. We'll just write previous is equals to null. I said you while showing the figure. Okay, I'll show you one more time. You can see the head, in the head the previous should point to null. So as we are adding one first new node, so the new node will perform as a head, so it should point in the previous, it should point to null. So let's go back. Okay, you can see here now we are pointing to null. And in the next, what should we point in the next? So just we'll write new node next. New node next should point to the next. It should point to the head. The head we declared here, it should point to this head. Because we wanted that whatever is entering, it should enter in the head. The first one, when nothing is added in the node, you can see the node, it is created in default in null. Nothing is inside this. So we just need to pass the one that will pass here, that is the node reference. We'll just write node and reference. Okay, now we are just in the next we are passing the node reference, means in the next it will contain the head that is null. So this will perform it because in the previous it is null and the next also it is null, means there is only one node. Now what if the node is not null, means the node we created or the head reference, means previously when a node is already present, what should be done? So we'll write if our head reference, so we'll just write if our node reference is not equal to null, means initially there were some data inside it. So what should we do? So we'll just put it inside the next so that we can do it. So we'll just write head reference previous, we'll just write node reference, we'll just write node reference previous should point to the new node that we just created, new node. I hope you are getting this. Okay, I'll say one more time what we are doing here. So we are checking if there was a node earlier present. This will be created automatically, but we'll check after creating this. We'll check that if there was already a node present, means our this node, the node we created, is not null now, because initially we already added a node. Then it should be like in the previous, it should point to the new node, means we wanted to add in the front, so that this is the head. You consider this as the head. In the previous, it should be the new node. Okay, now we need to do one more thing. Now this should behave as the head, because what is entered before head is the present head. So we can just write node reference will contain now the new node. So what we did here is that in the previous it will enter the node. Now we wanted that the new node should be the head, because whatever is entered in the first, this should always be at the head. So if you just save it and try to run this, I hope we will not get any result. Okay, we are not getting any result, means everything is correct till now. So I'll do that for the displaying. After displaying, we'll learn one more time. So we'll create one more function called void display that will take one more node. We'll take the node and we'll print out whatever was inside this. So we will create an instance of node. We'll just take a node here, and now we'll display whatever was inside the node. So before this, I'll try to add one more node. I won't say you why I'm adding it now, because I want it should be a new thing for you to learn in double linked list, sorry. So we'll create one new node. We'll name it temporary, so that you can give it any name, it's up to you. So now we'll write if our node is not null. Just for printing like we did in the previous, we'll just write if our node was not null, means the node that we passed is not null. Then what should be done? So we'll write if node not equals to null, just print out all my data. So we'll just print out all the data that was inside this node. We'll just write cout node data. We need to print out all the data that is contained inside the node, and next we need to change the node. We'll just write node is equal to node next. I hope you're getting this. We're getting this error, but this error will be gone very soon. There is nothing in this error. It will pass away. Don't worry about this error. This error will be gone. Okay, but before this, we created this temporary. Why we created? We'll add one more thing here. We'll just write temp is equal to node. This may seem like new thing, but you'll understand when we do it. So we'll just write one more while loop. While temp is not equals to null. Okay, while temp is not equal to null, we need to print out cout temp data temp is equals to temp next. Okay, this we created for displaying. I think we are not getting some lines, but when we run it, you'll understand it automatically. So now just let's save it so that we can. Now we'll add some node. We already added a function how to add node. Now we'll add some node. We'll just call the function. The name of the function was add node. You can see here this function should be called now add node, and we should give two arguments. First the head node and an integer that needs to be added. So let's go here and we'll write add node, and we need to pass the reference of this head. We'll just write head and an integer. Let's pass 1 for now, and we'll create some more. Let me create some more after this. So you can see that I created some more node like 1 2 3 4 5. I passed the value. Now if I just run this, okay, if I run this, we should not print anything, but we should not get any error also. You can see in the right hand side there is no error, means we are not, everything is right till now, we are not facing any error. Now let's display them what we printed. So let's just call the display function. The name of the display function was just display. Okay, we'll just write display and we'll pass the head inside it. And if you just run this now, you can see two things are passed here. Okay, I'll just clear out this and show you. Okay, I just added this line so that there is a difference between these two things, why we wrote this for you to understand. So if you just run this now, you can see there are two numbers 54321 and 12345. Okay, I'll just put some things here. I'll just write A and D L here once and one more time here. Okay, now if I run this, you can see clearly that first we are printing in the backward direction and secondly we are printing in the forward direction. This is possible in linked double linked list because we can go to the previous. You can see that in the second one, uh, the temporary node that we created, we went to the previous, means in the previous node, means in the first while loop it is printing in the backward direction, means the last node created will be printed first and it will just go in the next till the first one is reached. So this was created first, this will print in the last, whereas the last one printed will be in the first. It's like in the it's like stack, like last in first out is that type. And while in the second while loop you can see that we are printing the previous, means we are going in the backward direction, that's why we are printing in the forward direction like 1 to 5. That is the main advantage of double linked list, that we can go in both the direction, either in the forward direction or in the backward direction, and we can get whatever value we have assigned. So I'll try to tell it from the first one more time so that you don't face any difficulty. Let's go to the top. First of all, this two line is clear to everyone, I guess. Okay, let's come from 6. We created a class called node where we added 3 members. First is the data that we want to take as an input is type of integer. You can take it any data type, it will work for everything. Second, we created 2 instances of node because in double linked list we have 2 pointers, previous and next. So this will point to the next node and this will point to the previous node. Okay, now we'll do one functionality, that is insertion and displaying. Means we want to insert nodes in the front of the head and we'll try to display whatever the node is inside it. So we created a function called add node in which we passed a reference to the node reference, means the head. Also in the int main, what is this, and we'll pass an integer type that need to be assigned to the data. Okay, now we come here, we created a new node called new node. You can name it anything. So this is the new node, so that we whenever we come to this function we'll create a node that will be added. So this is the node that to be added called new node, and in the new node we'll pass the data that was passed in the function in this int n, okay. Then after this, in the previous, I said in double linked list, the first one, the first means the head should point in the previous, it should point to null, and the tail, the last one in the next, it should point to null. So first of all, this the head was null. You can see in the int main, whenever this node was created, it was created in null. So we want that whenever a new node is created, it should be in the head, means the previous should be null, because we are doing it for insertion in the front. When we do the and, we'll not add all this, we'll add some more different functionality. So this is the for the first node, so in the previous it should point to null, in the next it should point to the head that was earlier present. For the first time it is pointing to null because first of all the head was in null, and this is the main concept of double linked list, that the first one in the previous it should point to null and the last one in the next it should point to null. I hope you are getting till now. If my pace is too speed, you can comment out and I'll try to solve it in the next. Okay, now we created a if statement. Suppose in the head there is already a node, means a node is already present, means our this double linked list is not empty. We're writing that if our head is not empty, means there is some node already in our head. Then we'll write that in the previous, the head in the previous it should point to the new node, because we want that this new node should be the head because we are inserting it in the front, and in the end we are just writing that this the head should be equal to the new node that we just created. Okay, now we are for displaying it, we just added a function called display and which we pass the reference to the node. We created a new node because I wanted to show you how to print out in the both the direction, in the forward direction as well as in the backward direction. So we created a while loop. We are checking if the node that was passed by reference is not null, just print out the data and include whatever the in which node you are. This node should be copied in this temporary node that we just created, and just go to the next node and print out the node data. We created one more while loop. Before while loop we added this so that we wanted a gap between the node, you can see here. We added a gap between the node in the result. We create, now we wrote while this temporary is not null, means the new node will not be null because we added whatever was inside this inside node, we copied it in temporary node. We just printed out the data, but this time we did not go to the next, we went to the previous because we wanted to print it in a serial way. If you go to the next, only one will get printed, only this, because after this it will be null. So that's how we did print out. And this is how we added node. We call the function, we passed reference to the head, and we gave the integer type value. And for display, we just wrote display and we passed the head in it, and that was it. So this was the main, it is a basic how to add and how to display. I hope you got the basic concept. If you are facing any difficulty, even a single line, you can just comment out, and all the link will, means the code will be on GitHub, so that you can take reference. So in the next video we'll do like insertion in different, there we did in the head, means in the front, how to do it at the end. So in the next we'll run insertion in the end and random position, means we want to add in different place. You know that a linked list gives us a functionality that we can add anywhere, the node can be added anywhere wherever we want. So we'll do insertion in the end and in the random and deleting in the next video, but before going to the next video, you should get this video concept very clearly so that we can move to the next. If you're facing any difficulty, please comment out. You can give feedback to the channel so that we can improve. And then thank you for watching. See you in the next, and have a good day. Happy coding.